So this video is brought to us by the Rock Raider Man. Fun little guy. He carries crystals in his belly. Okay, so we've calculated a mean of a data set, but what if we hand you a grouped frequency distribution and ask you to find a mean of this? The problem is you can't find the mean because we don't know the data values. But we can approximate a mean by finding the midpoints of these classes and pretending like those midpoints are the actual data values. The author gives you a nice little example to run through here and says, hey, the way to, it actually doesn't tell you how to find the midpoint, but the way to find the midpoint is the middle of the lower limit and the upper limit. So how we would find that is take 100, add to it 104, divide by 2. This is 204 divided by 2, we get 102. That would be in the middle of this class. So if I were to do the midpoint, this would be 102. Now, in our stats class, we find the midpoint by adding together consecutive lower limits. Slightly different method. So just note that there are different methods for finding the midpoint. So we would do this for all of these, and then what we're saying is there are 3 data values that are equal to 102, and we calculate the mean of that. So we would do 102 times 3 plus whatever this midpoint is times 8 plus this midpoint times that, add them all up and divide by how many data values we have, and we've got the mean for this grouped frequency distribution. It's an approximation, right? Because we don't know the actual data values. But it's going to be a pretty good approximation because 102 is pretty close to the data values that are all in here, right? There are 3 data values that are between 100 and 104, and if we're averaging them all to be 102, that's a pretty good approximation. All right, let me run an example for you. Oh, here's the steps for finding that midpoint, so refer back to this. Here's the formula, which isn't particularly helpful. I'm going to show you how to type this into Desmos. And that might be a little easier. Again, if you've forgotten, this X bar means sample mean. That's what that symbol stands for. So just a reminder, why is this formula given approximation, not the actual mean? Because we're not using actual data values. We don't have the exact data values. Okay, so here is a group frequency distribution for the selling prices of 95 homes that were recently sold in our author's town. We want to find the mean selling price of these homes. Well, if we follow his strategy for finding the midpoint of this first class is 101 or 100,000 plus 200,000 divided by 2. So that is 301,000 divided by 2, which is 150,500. That's the first midpoint. The second midpoint is the 201,000 plus the 300,000 divided by 2. Let's see, that's 501,000. Divide that by 2. And what do we get? 250,500. At this point, we can see the distance between these values. The width is 100,000. And actually, we could have seen that back here. We add 100,000 to 101,000. We get 201,000. So the next midpoint is just going to be this value plus 300,000 or plus 100,000. So the very last midpoint would be 350,500. Those are our 3 midpoints. So to get the mean, we're going to multiply the frequency, the number of homes that were sold in this range, times what we're claiming all the homes were sold for, right? We're literally saying every single home in this class was sold for 150,000, approximately. So we're claiming there's 64 of those, plus the 250,000 times 500, or 250,500. There were 26 homes sold at that price, plus there were 5 homes sold at the 350,000 mark. We're going to add those together, and then we're going to divide that mess by the total number of homes sold. That's the sum. That's the total frequency here. Let's see, 26, 80, 95. There were 95 total homes sold. I'm going to type this in Desmos because it looks a little cleaner in there. And the way I'm going to do this is I'm going to start with a fraction. And in the top, I'll do the 64 times 150, 500, plus the 26 times the 250,500, plus the 5 times 350,500. Remember, don't put commas in there. And then the bottom, I'm going to write it out this way, 64 plus 26 plus 5. So you can see that that's the sum of the frequencies. Note that 64 plus 26 plus 5 is the 95 I said, but this is maybe helpful to keep track of how this formula is working. It's the frequency times the midpoint, all of those added up, divided by the sum of the frequencies. So the mean selling price for those homes in his neighborhood was $188,394.74. Not bad. Okay, it turns out that your course grades, the final grades in a class, are also calculated like a grouped frequency distribution, except that we do them really in terms of weights. Now, our class does it a little different. I don't do points, I do percentages, which if you look at this, we can convert this into a percentage scale. So what this is saying is you get 50 points for your homework average, 30 points for your tests, 50 points for your final exam, and so on and so forth. If we add these together, let's see, 50 plus 50 is 100, and then 150, 160. This is 160 points. What we could show is that the homework average is this percentage of your overall grade. So I'm going to scamper over to Desmos and see that 50 divided by 160. Oh, it's 31.25% of the grade. That's how you would convert a points scale to a percentage scale. If you look at your syllabus under the grading rubric, you'll see that homework is 12% of your overall grade. All right, so our goal then would be to, well, what we do is we call those percentages the weights. They're kind of like the frequencies, and then the grades you get in those categories is your average. So we're told that there's a particular student that got these grades, and they're different in these different categories, and we want to calculate their final grade in the course. We're going to do this in Desmos, and what we do is we take this percentage, this 87%, we multiply it times the 50, we add to it the test scores. Now, if you recall, each test score was 30 points each. Oh, I'm sorry. I should have added these 30 points together, so it shouldn't have been 160. So this is wrong. The 4 tests are a total of 120 points. So I need to change what that total is. But so each one of these tests is 30 points, so it would be 0.91 times 30 plus 0.82 times 30 plus 0.86 times 30 plus 0.94 times 30. I'm quickly running out of space to get this all in. The final exam, that represents 50 points. So 88 times 50 plus the group projects, or project, I guess it's just one, that was 20 points of the final grade. And attendance was 10 points. Good job. This student had 100% attendance in the class. So we're going to add these all up, and then we're going to divide this whole mess by the sum of all these things. 50 plus 30 plus 30 plus 30 plus 30. There's the 4 exams. Plus 50 plus 20 plus 10. And this is going to get Tong's grade in the class. Let's type that into Desmos and see what we get. You might be thinking, oh, this is tedious. Couldn't we do this? Isn't there a better way to do this? And maybe the answer is Excel might be a little bit nicer. I don't know, not a whole lot nicer. You have to type it in either way. To me, that's the part that's a bit tedious. Okay, so there is all of the grade percentages times the points for each, and then I want all of that to be divided by the sum of each of those point values for the categories, so the 50 and the 30 and etc. So 50 plus 4 30s, and then another 50 for the final, and a 20 and a 10. And there is the percentage for this student. Now we could have left the percentages in as in like 92 and the rest, and this would have come out as a percent. Instead, we have to multiply it by 100 at the end, and we see that Tong ends the course with an 88.72% average. Not a bad grade. That, based on our grading scale, would correspond to a 3.5.